So I'm Jan Pieter. My name is very Dutch. I live in the Netherlands, but I'm actually Brazilian. My background is chemistry and petroleum engineering, and I'm going to share my screen. Yeah, this one. So I'm going to present today for you nature's principles, and we are focused on lactic acid production from a new technology that I'm going to tell you how. But first of all, we all talk about carbon emissions and how to make the whole carbon production more clean. But what we don't talk about that often is that 84% of our carbon production nowadays is from fossil-based chemicals, which means that if we reach 2050 without any fossil-based, we need to reinvent the whole industry because 84% of the production will be just gone. Then we need so many options, so many alternatives to tackle this problem that but we need to separate which ones really make sense. And for us, what makes sense is to focus on the bio-based chemicals because the technologies are ready to scale so that we can really make a change as fast as possible. And then we keep on researching on other more future possibilities later. And one of the key chemicals for us to support this change is lactic acid. It's being used for so many things in biopolymers, preservatives, biocides, solvents. It's already replacing oil and gas in many alternatives, and that's why it's so much of a growth market. Nowadays, it's around 3 billion. It's going to reach 6 billion by 2030, 8% growth. And because of also every time we see other applications being developed for the molecule. And also we chose this molecule because we can make it better. We can reduce 30% of the OPEX, the production costs on the production of this molecule, because without technology that is patented, we started in Delft University in the Netherlands. We are flexible, we are agnostic on the feedstock. So instead of using refined sugar, instead of using corn syrup in the US, here in Thailand, crystal sugar, we can use side streams, residual streams from the industry, or even cellulosic material to ferment this and produce lactic acid. And with this we can reduce 40 to 70% the sugar feedstock cost, and not competing with food. Sugar competes with food, so why should we use sugar to produce our chemicals in our daily basis? So there's a lot of discussions going on about it, and we can solve this discussion. And so we see our technology as groundbreaking because we can really change the way we produce lactic acid nowadays. All the industry is using sugar. We don't need that. We don't need to compete with food. We don't need to refine the sugar that much and use all this energy to do that. And because of that, we decrease so much the cost of production that we can even be profitable on a size of 2 to 5 kilotons instead of 75 to 250. And this is what we want to do on our demo plant. Our demo plant is 2 to 5 kilotons, and it can be profitable, which is already groundbreaking. And so we already did our pilot. We have our facilities in Rotterdam nowadays on the industrial area, and we tested sugar beets, the raw sugar beets, and we got good results. Now we are going for lactic acid producers to make joint ventures to produce in large scale. But first, before that, we want to build our demo plant for a beachhead market, produce 120 tons already next year, and go into 2,000 tons by 2028, and then go for the flagship plant, 55 kilotons, using our technology. This is our team. We are 2 co-founders and directors. I'm Jan Pieter. Jules Rombout is the PhD that developed this technology in Delft University. And we are 5 FTE full-time. focus on fermentation and chemistry. And we also have our mentors, advisors. They're also in the industry on financials and on lactic acid production. So this is us. We produce biochemicals. They are naturally sustainable using the principles of nature. If you feel a fit with what we are going for, please reach out to me.